All right, I think we're going.
All right, here we go. A system of two linear equations in two variables x and y, also called a linear system, consists of two equations that can be written in the following form: ax plus by equals c, dx plus ey equals f. A solution of a system of linear equations in two variables is an ordered pair, x comma y, that satisfies each equation. Solutions correspond to points where the graphs of the equations in a system intersect. So we're going to start in example 1. We're going to graph each line and estimate the solution. So here we go. We're going to start with 4x plus y equals 8. Now this is in standard form. So let's do the intercept method. So we'll make an XY table. And what's really nice about this is I can cover up the 4x and y is 8. If I cover up y, I get 4x equals 8, so x is 2. Now I'll change colors. Maybe. If the board will cooperate. 2x minus 3y equals 18. So you try it. Let x be 0. If x is 0, we get negative 3y equals 18. So y is negative 6. Let y be 0. And I get 2x equals 18. So x is 9. So something I want to point out to you is when you're doing your grid, it does not necessarily have to be your XY coordinates in the middle. The other thing is, when I look at these values, you really do want to think, okay? You want to think through. My y needs to go from negative 6 to positive 8. If I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I don't have 14 spots to go by ones. So you want to think about it before you start making it. I know on your graph paper, oftentimes you can keep going up, but do you really want to do that? So on my y-axis, I'm going to go by 2's. And please indicate your scale. Okay, indicate your scale. Now, on the x-axis, I can go by ones, and you are allowed to do that. You're allowed to go by ones on the x-axis and 2's on the y-axis. So now I'm going to try to be consistent here with my colors. If I have 0, 8, and then 2, 0, I'm going to draw a line. Oh, that's really bad. There we go, better. Also, when you're drawing your lines extended through the grid, you make it touch the boundary of your grid. So then if I have 0, negative 6, and 9, 0, let me draw that line. That was bad, sorry. And if you had to guess, what do you think the solution is? Does it look like I'm to the right 3, and now down 2 tick marks isn't negative 2. Remember we went by 2, so this is 3, negative 4. Now it says check your solution algebraically. What that means is that what we read on the first slide is that the solution, your x comma y, has to work in both equations. So we're going to take, this is 4 times 3 plus a negative 4. And you remember when we did inequalities and we were checking solutions, and I said, let's put a question mark because we're trying to find out if that's true. So I get 12 minus 4, so it works in the first one. And then let's check it in the second one. So I get 2 times 3 minus 3 times negative 4 equals 18. 6 plus 12, that works. So when you're graphing a linear system, you graph each line, and then you're estimating where the solution is. And then you check it algebraically. I'm okay if you do the check mentally, okay? We're at that level that I think we can check them, but make sure you check it because you might be able to find a silly mistake. Any questions on example 1? All right, then take out your graphing calculators, and I want to show you how you can actually use the graphing calculator to solve your system. What you're going to do is you need to solve each equation for y equals mx plus b, and then leave space here. We'll write some more notes to help us, okay? But here we go. If I subtract the 8x and then divide by, say, negative 1, there's my first equation. Then let's take the second equation. I'll subtract 3x from both sides and divide by 2. Okay, does everybody have the 2 equations? Now here's what you're going to do. Take out your calculators and go to your y screen, your y equals button. And we're going to enter the first equation, 8x minus 8 in y1. It's very, very important that you stay with me here, okay? Make sure you're all in your y screen. Now, when you go to do y2, all fractions in front of the variable have to be in a parenthesis. So watch carefully how I need to enter this. Okay? Otherwise you're going to get wrong graphs, which we don't want to have happen. So you need to enter the negative 3/2 in a parenthesis. Because if you don't, sometimes the calculator will put the 2 and the x together and you'll get a wacky looking graph. Also, before we go to hit graph, I want you guys to check across up here. Make sure your plots are off. These should not be highlighted. If yours has like a black box around it, your plots are on. Go to second, y equals, and turn them off. But if they're like mine, you're fine. All right, I don't remember what I was graphing last, so let's do zoom 6. Zoom 6 puts it on the standard window. And on the screen, we can see they're intersecting. Now here's the really cool part. And I'll write all this down for you when I get back to the slide. But here we go. Press second, trace. Again, second, trace. And we're looking for the intersection, aren't we? That's number 5. So press 5. And it says first curve, you press enter. Second curve, enter. If your flashing cursor is far away from where they're intersecting, you use your arrow buttons and get closer. Ours is looks like it's on top of it. And so look, it'll find the intersection for me at 0, negative 8. Okay? So let's go back to the notes. Solve each equation for y equals mx plus b. Enter both in the y equals screen in y1 and y2. Then you press graph. Then you do second trace, and then you press number 5, intersect. And then you press enter 3 times. You just press enter, enter, enter through first guess, second guess, or first curve, second curve, guess. Okay? Alright, any problems, any errors? First period we had a lot of, oh, I'm getting an error message. We're all okay? Okay, then let's look at the box. It said number of solutions of a linear system. What we've seen so far is exactly one solution where the 2 lines intersect. If you get a solution, it's called consistent. Consistent means there is a solution. Okay, consistent means there is a solution. Independent means there's 2 distinct lines. Independent means there's 2 distinct lines. In the middle grid, there's 2 lines that are the same. Okay, there's one on top of the other. So there's infinitely many solutions. So because there is a solution, it's called consistent. But it's dependent because it's only one line. So you have 2 equations, but they graph the same line. In the third picture, these are 2 parallel lines. The solution to a system is where they intersect. So there's one solution, one intersection. Infinitely many intersections, infinitely many solutions. There's no solution, so this is called inconsistent. There are 2 separate lines, so it's independent, okay? Independent means 2 distinct lines. Dependent is one line. Consistent means you have at least a solution. Inconsistent is no solution. Okay? Alright, now, if you have a system with many solutions, let me show you how you can solve this. I'm going to jump ahead a little bit on tomorrow's lesson, but it's a review from Algebra 1. Do you remember the elimination method, where you could multiply one or both equations to eliminate one of the variables? So if I look at the 4 and the 8 in front of the x, if I could multiply that by a -2, and then line it up with the second equation, now the x's have opposite but the same number. Opposite but the same number. Well, what ends up happening then with the elimination method is you add these, and the variable drops out in the infinitely many solutions case. And you get a true statement. 0 equals 0 is true. So there's infinitely many solutions. So it's consistent because it has a solution, but it's really the same line. So it's dependent. Okay? All right, in example 4, because these are easy enough, let's solve each equation for y by subtracting 2x from both sides. So that leaves me with y equals -2x plus 4 and y equals -2x plus 1. So let's go to our y screen and enter these in y1 and y2. So I get negative 2x plus 4, negative 2x plus 1. Remember to use the negative symbol and not the subtract. If you get an error, you probably used the subtract sign incorrectly. The other thing is when you're getting an error on your calculator, one of the options says quit and the other says go to. If you want to figure out what the problem is, go to it and it actually will sit right on top of the problem for you. Okay? Alright, let's press graph. And these appear to be parallel, but let's suppose we shut our brains off for a moment and we're just going through process. And we say, okay, we enter it in y1, we enter it in y2. Let's do second trace, intersect, enter, 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 and it says error. Okay? It doesn't work because there is no intersection. So I wanted you to know that if it does that to you. So they're parallel. Parallel lines have no intersection, so there's no solution. That means it's inconsistent because there's two separate lines. They're independent. Okay, what I'd like you to do is go back to your warm-up section. And I'm going to give you one that I want you to try to use your calculator on and see if you guys can do the whole process on your own. Okay, do y plus 3x equals 5. Y minus 2x equals negative 5. Okay, try this on your calculators.
Sorry for the...
Alright, did you guys get 2, negative 1? Yes! Okay, good job.